again. Yes. Okay. So the topic which I need to discuss, the first topic, which is the easiest thing, I guess you all know, that is test for unsaturated, test for unsaturation. That is most commonest question in O levels, IGCSE or A levels. That is test for unsaturation. Saturation and unsaturation means, saturation means carbon-carbon single bond. This is saturated compound. Okay. Saturated means alkane, and unsaturated means carbon-carbon double bond. And we have to check unsaturation. I mean, the name of the topic is test for unsaturation. How to check unsaturation of the compound. So we are going to discuss the unsaturation of the compound. How can we check unsaturation? The upper one is saturated. Let me write. This is saturated and this is unsaturated. For example, we have these things in a container and I want to check that, for example, this is A container and this is B container. So I want to check that which container has unsaturated compound. How can we check? The name of the test is bromination. The bromination. We have to do the bromination here. Bromination is a test by which you can detect the presence of unsaturated compounds. Okay. How can it check? Let me tell you. We are doing bromination. So how to do bromination? We have to bring a bromine water. You all know that we have halogens like fluorine, chlorine, bromine, iodine. Fluorine, chlorine are the gases at room temperature, while bromine is liquid at room temperature, while iodine is solid at room temperature. So we are using bromine, I mean Br2. We are using Br2. Bromine is liquid at room temperature. It means we are using bromine water. Bromine is liquid at room temperature. I am testing unsaturation. I mean, I'm checking that which container contain unsaturated thing or unsaturated compound or unsaturated hydrocarbon. So I'm doing bromination, means I'm using bromine water. What I have to do, I have to add bromine water in Br2, the bromine water in both of the container. Bromine water, you all know about the halogens. They have different state at room temperature. They have different density. They have, for example, there are a few halogens which are solid at room temperature, like iodine and the acetylene. Bromine is liquid at room temperature. Fluorine and the chlorine, they are gases at room temperature. And there is one more dissimilarity between them. No? I mean, the dissimilarity is the colors. So we are using Br2 here, that is liquid at room temperature. What is the color of Br2? That is reddish brown, a brownish red, or reddish orange, or orangish brown. Everything is same. It's up to you, whatever you want to use. I mean, that is something like reddish brown or orangish red or reddish orange. Everything is same. It's up to you what color you are using. The simple is that it is something like reddish. Okay, so we are using Br2 here. I am adding bromine water in both the containers or in both the test tube. For example, we have alkane, I mean, in A test tube, and we have alkene, the unsaturated one, in second test tube. And I am adding bromine water, which is reddish in color in both the test tube. Okay. Bromine water has red color, and ethane are the gases. So when I am adding Br2 in first container, so everyone knows that first container contain ethane, which is alkane, and I am adding Br2. So addition reaction is not possible in alkane. So most of the students tell me, Miss, you can do some substitution here. Means you can make bromine a free radical and then it will attack the bond and then there will be some bromoethane like something. For that you have to use sunlight here. We are not using sunlight here. We are doing it without sunlight. So you don't have to discuss any free radical type thing, which we discussed in a previous class. Forget about the free radical now. So in alkane, addition reaction is not possible. So the bromine cannot be added in a test tube, in alkane, in saturated one. So when you add bromine water in a test tube, in upper one, in this one, it will remain red. You can see some red liquid in the test tube. But when you add this bromine into the second test tube, which contain ethene, the unsaturated one, so you all know that addition reaction is likely possible here. I mean, there must be addition reaction. This bromine will break the double bond between the carbon, and one bromine here and one bromine here. So you will get some liquid thing, but that will be colorless because there is no Br2. Now there is bromoethane. We never discussed that bromoethane has red color. No, this is Br2 which has red color. Now there is no bromine liquid because bromine has been added into the ethene and it will decolorized. This is how you can check unsaturation. This is so simple. For example, if this is a test tube and it contains alkane, carbon-carbon single bond. Alkanes are saturated. If you are adding bromine water, which is actually red in color, so you can see the red liquid. Reason bromine water, or you can say the bromine cannot be added into alkane, into the saturated one, because addition reaction is not possible here. Substitution reaction is possible. For that, you need sunlight and all that stuff. So don't think about free radical thing here. Okay, let's move. Let's bring another test tube. Let's add some ethene, means double bond structure, means alkene, means unsaturated thing. Now you can add bromine water here. So bromine water is reddish in color. So you can see reddish liquid in first test tube, which has alkane. But when you add bromine water in second test tube, it will decolorize. Reason? Because now there is no any bromine water. The bromine water has been added into the alkene and it has become the bromoalkane. In A test tube, this is A and this is B test tube. So in A test tube, there is no addition reaction. In A test tube, there is bromine water and ethane in A test tube. So you can still see the color of the bromine water. But in B test tube, there is no bromine and ethene now. Bromine has been added into the ethene and that is giving you bromoethane. There is no bromine water now, so you cannot see the red color of the bromine. So the liquid will be decolorized. This is how you can check unsaturation. And this is how you can check the presence of alkene. The bromination is a test for unsaturation. This is the most commonest question in your past paper. Let me check if I'm missing anything. Okay, so this is all about test for unsaturation. Let me check if we need to discuss anything else. I have given you one homework in which you have to use hexane for um, initiation or propagation or termination. Like you have to do some substitution reaction with the hexane, and you have to mention each and every step, including homolytic fission. You have to use word homolytic fission. You have to tell them that we are doing homolytic fission. The fission is not heterolytic. You know, if the fission will be heterolytic in the previous class, for example, the heterolytic fission will give you chlorine negative, and other chlorine will be positive because this chlorine has taken away electron from the previous from this chlorine, from the first chlorine. This is not radical. Radicals are neutral all the time. Radicals cannot be positive or negative. So we have to do homolytic fission. That is a topic of previous class. So this is all about the substitution reaction. I have wait. There is one more thing which we need to discuss. Okay, I got one more thing. That is, okay, alcohols. Actually, I can see some questions from your past paper that is called substitution of alcohols. Substitution of alcohol. Let me show you one substitution for today's class. I am using the commonest alcohol. I mean, this is very easy to learn reaction with the ethanol. That is the easiest alcohol. Okay, what we have to do? Substitution of alcohol. And definitely we have to go for substitution reaction because there is no any double bond, so we cannot add anything. I am reacting this alcohol with HX. X means halide. Halide. X could be chlorine, X could be bromine, X could be iodine. So what will happen? This X will replace OH. You will get this thing. Hydrogen, there will be hydrogen, there will be hydrogen, there will be X, and this OH will be attached with hydrogen. And this will give you water. What is X? Any halide. You can use chlorine. So it means we are using this alcohol with HCl. So H will react with the OH, it will give you water, and chlorine will be here with the carbon chain. You will get haloalkane. There is one more thing. For this reaction, we need a catalyst. And that's what you should know. We have to use catalyst here. Reason? HX is halide. Means it could be HCl. For example, I have taken HCl here. See, this is HCl. That is not free radical. And alcohol is all saturated. That is also not free radical. That is not that much reactive. So we need a catalyst now to speed up the reaction, to lower the activation energy. So what catalyst we can use here? We can use acid. Acid could be okay, H2SO4. You can use H2SO4 here. Let me write it here. And you can see your book, they are using H3PO4, the phosphoric acid. You can use both of them. But I can see that your marking scheme is showing H3PO4. Basically, both are correct. You can use H2SO4 because few writers, I can see H2SO4 in few books, but your marking scheme is showing H3PO4. And the marking scheme of another year is showing H2SO4. It means both are correct. Yes. So for the substitution of alcohol, it depends. If you're using HX, X could be any halogen group, for example. So you have to use H2SO4 or H3PO4 as a catalyst here to lower the activation energy or to speed up the reaction. Let me check if there is anything which need to be discussed. I guess this is enough for today. You will get confused a lot because we have already discussed the most difficult topic, which is substitution reaction with all the steps. So let's end class here. And in next class, let me tell you the topic of next class, what we have to do. Let me check. We have to do some more reactions of substitution of alcohols. 1, 2, 3, 4. There are 4 more reactions of substitution of alcohols. And then we have to discuss electrophile and the nucleophile. We have to discuss their reactions, like electrophilic addition reactions of alkenes. We have to discuss that in detail, and that then we have to discuss the nucleophilic reaction in organic chemistry. We discussed the basic example, the basic structure of electrophilic and the nucleophilic reaction with the example of H plus and OH negative. Now we have to discuss electrophilic and the nucleophilic reaction with the organic compounds, which are included in your past paper. So see you inshallah tomorrow, and we can discuss all that stuff in upcoming class. So I have given you a homework. You have to do that reaction with hexane. Give it a try. If you feel any issue, you can tell me. I'll help you out. Okay, take care. Allah Hafiz.